a phantom. The scientific term EntThe was entered as a discovery in the dictionary, then remained as a mistake. Picture a tiny spark in a dark room, flickering in chaotic little bursts. Never the same twice, always shifting just enough that your eyes start telling stories about the light. Looked like science. It felt like science. But the only thing that changed was the observer's perception. Perceiving what? Maybe you've never heard of this EntThe, or how dozens of excited, ambitious scientists thought it was a huge breakthrough. But in 1903, Prosper René Blondlot, a respected French physicist with a spotless reputation, believed he had discovered a new kind of radiation. The world had just been dazzled by X-rays and radioactivity, so the idea of another invisible force felt almost inevitable. Blondlot worked in a dim laboratory in Nancy, France, staring at a tiny electric spark that flickered in the dark. Yes, this was his job, to stare. Why? Because he had started a short experiment to see if X-rays were particles or waves. But then, the whole focus changed because Blondlot thought he saw the electric spark flicker when he exposed it to the X-ray. He believed this flickering was evidence of a never-before-detected ray. He named it the EntThe, after his city, Nancy. What happened next is one of the strangest episodes in scientific history. Not because the discovery was wild, but because so many people agreed they saw something that wasn't there. At first, the detector of the EntThe was nothing more than that spark, a raw, flickering point of light in a dark room. It was simple, almost rustic, and he showed the spark to others, trying to reveal how it changed when he exposed it to X-rays, asking students, colleagues, and assistants if they could see the spark brighten slightly. Politely, they said kind of, or sometimes. Who wanted to disagree with a respected physicist? But visiting scientists were more straightforward, giving Blondlot a flat no. Very quickly, scientists began to feel that Blondlot's method of detecting the EntThe was a little too homemade, too close to, I stared at a spark and felt something. So within months, Blondlot decided to switch to a detector that might enhance the effect for those who didn't see it. One that at least had more substance, a dim phosphorescent screen. Its glowing surface was supposed to make the brightness changes easier for others to see. So now we're looking for shifts in brightness on an already glowing surface. A tad like a funhouse illusion maker. But to colleagues, using something other than Blondlot's eyes made the study more scientifically realistic. It kept the study of these EntThes going, at least.
Blondlot.
But was incorporating glow-in-the-dark screens more psychological than technical? The glowing screen feels like science, even if its glow is very faint. So the community gravitated toward the tool that made the research feel more legitimate, this phosphorescent screen, even if it actually made the illusion stronger. You might call it sincere pseudoscience, or just a group of people trying to give more weight to something that apparently wasn't really there. Invisible ray? Hysteria. But once the glowing screens arrived, the claims actually multiplied. The unintended illusion turned out to be pretty satisfying for them. Scientists made all kinds of weird claims about the supposed rays. They said EntThes came from the sun and from heated metals, even from the human nervous system. They said the rays could be bent with prisms, reflected with mirrors, and stored in bricks like invisible batteries. One researcher even claimed rabbits emitted them, which of course raised more questions than it answered. Yet they would come to believe that EntThes were emitted by almost everything, with the peculiar exceptions of some treated metals and green wood. Soon, nearly 300 papers were published on EntThes. Laboratories across France were buzzing with experiments. The more people looked for them, the more they found them. But outside France, skepticism was growing. British and American scientists tried to replicate the experiments and saw nothing. They weren't sure whether the French were mistaken or simply seeing what they wanted to see, which was, to be precise, the varying light changes within the flicker's isolated sparks. I mean, we're talking about irregular, chaotic flickers. Imagine a flame in the wind, but shrunk down to the size of a pinhead and jittering with electricity instead of air. Try documenting that by eye sometime. Yet almost no one outside France saw the rays in their experiments. Odd. Just gotta ask, was it the local wine or just the professional atmosphere? But mostly forgotten by then was that early similar properties of another unknown radiation had been recorded in Austria and Germany in 1850, and in Vienna back in 1779.
Yes, I see the ray. I see it.
Similar stuff, but sources say Blondlot probably didn't know about those accounts. So, time-traveling phenomena or traveling atmosphere? Ah, I know. Traveling wine, perhaps. Well, when it became clear that apparently only France was seeing the N-rays, Robert W. Wood entered the story. Wood was an American physicist known for his sharp eye and sharper skepticism. He traveled to Blondlot's lab in 1904 to witness the phenomenon firsthand. And what he saw was a phenomenon in itself, the apparatus. Blondlot could have used a spectroscope or even an electroscope. He was, after all, a respected scientist. But instead, he used this apparatus that consisted of an aluminum prism in conjunction with the glowing screen, which inadvertently served as an aid to persuade more observers' eyes. The strange apparatus. The whole goal was to detect and confirm the N-rays using the apparatus. Now, it's not a museum-quality account, but here's the gist of it. According to Blondlot, the electric spark, when exposed to X radiation, created these unseen N-rays. He was making the rays visible through an aluminum prism, which refracted N-rays the way a normal glass prism refracts light. His prism was roughly the size of a matchbox, a flimsy little thing, really, the kind that might blow away in a good autumn wind, but it was mounted on a simple stand, indoors. Now, the screen concealed the sparks, the prism, everything. Sounds like pretty odd engineering, right? Blondlot thought N-rays were like X-rays or UV, invisible rays that could pass through materials. He thought the rays could be refracted by aluminum to strike the back of the screen and cause a brightness change on the front of it. So the idea wasn't to shine the spark directly on the front of the screen. Instead, the spark only needed to emit the invisible rays straight through the solid screen from behind it. Sounds sorta like a shadow puppet performance, but through a solid screen instead of a translucent one. Or like the leftovers of a super crude early TV? Yeah, one from a parallel Earth. So when researchers sat a few feet from the phosphorescent screen, they only saw the screen, glowing faintly. Everything else was out of sight. Behind the screen was the prism. Behind that, an upright card with a paper-thin slit down the middle of it. And behind that, the spark, emitting the invisible N-ray. Mostly in that order. Or maybe this order. Whatever the case, everything was arranged on a table in a straight line, in the dark. I can just imagine people sitting in a tight little crowd to get as close as possible to the experiment, mouth breathing in your ear. This had to be the most boring lab in history. I'd want to see something too, even if it wasn't really there. Well, in this dark room, the spark was faint, and here's Blondlot, narrating each individual brightness change with total confidence. When the world feels full of new discoveries, people might start seeing what they expect to see. The downfall. Wood, on the other hand, watched quietly. Then, during one demonstration, Wood, quite sneakily, reached over and removed the prism from the apparatus, a key piece that supposedly bent the rays. Blondlot didn't notice that sleight of hand, though. He continued describing the effects, exactly
Luke
as
8.
before.
The texture of this surface.
Pretty sure that if Wood didn't raise a brow at that, he raised two, in the dark. In that moment, though, the entire N-ray empire cracked. Wood published his observations, and Blondlot read the piece, but was sure Wood had just misunderstood the whole experiment.
No.
But the rest of the scientific world realized that the rays had never existed. The brightness changes were nothing more than the eye adjusting to darkness. The sightings were amplified by expectation, nationalism, and the contagious excitement of discovery. The collapse wasn't instant, but it was decisive. Over the next 2 years, belief in EntThe evaporated everywhere, except Blondlot's own circle in Nancy. Journals retracted papers. Scientists who had sworn they saw EntThe quietly tiptoed onto other topics. I can imagine 1 or 2 would have changed their names, moved to Australia. Yeah, pretty embarrassing. The end product. The humor is in the human mistake that so many people thought they saw the same thing. Can we say the same absurd thing? I guess that depends. Neuro breakthroughs that allow patients to control their limbs with an implant would have sounded laughable to these guys. Science has that craziness quality. It's sort of like a grab bag. You never know if what you're chasing might turn out to be a great discovery or a dud. Because human imagination is actually an integral part of science. As long as humans are doing science, the two can never be separated, for better or worse. And eventually, we can laugh at our mistakes. On the other hand, the tragedy is in how enthusiastic those guys were in the beginning about the uses of the ray. Astronomers back then thought the EntThe could make stars look brighter. Others thought it would improve photography, reveal hidden structures in materials, and strengthen nerve activity. They thought that bathing eyes in these rays was supposed to make vision sharper, and that stones or bricks could charge up with EntThe and release them later. Why is that kind of tragic? Because geez, those things, if real, could have been useful to a lot of people. It was a pretty good basis for chipping away at a study to discover more, even if only to be fooled by the thing we're supposed to trust more than any thing in the world, the human eye, or even personal experience. That feels like a ripoff, even for those scientists back then. Blondlot himself, by the way, continued believing in EntThe for years, but the scientific community had already closed the book. In fact, the last solid evidence we have shows Blondlot still believed in EntThe at age 77, possibly later. Then he died at 81 as a once great physicist whose career had been dimmed, but not destroyed, by a sincere mistake. The heart of the trivia. And that's the heart of the story. EntThe weren't a failure of science. They were a reminder that science is a human process, shaped by the same hopes, biases, and blind spots that shape everything else we do. When people expect to see something, they often do, even if it isn't there. When a respected figure speaks with confidence, others follow. And when a discovery fits the mood of the moment, it can take on a life of its own. The EntThe fiasco is funny, yes, but it's also deeply human. It shows how easily authority can overshadow evidence, and how even the most careful observers can mistake their own perception for reality. It's a story about the limits of the human eye, the power of belief, and the quiet courage it takes to say, "I don't see it." And in that way, it's not just a scientific curiosity, it's a mirror held up to every system that insists it speaks for nature, when in fact it speaks for the people inside it. The rays of rabbits. But, as an afterthought, here's the real rabbit hole. There are people whose sensory systems sit at the far edges of the bell curve, tetrachromats who see colors others can't, synesthetes who perceive sound as shape, people with hyperacuity who can detect tiny light changes most of us miss. These exist. They're rare, but real. So the idea that a scientist might have an unusually sensitive visual system isn't absurd. It's just, well, statistically lonely. There's always a slim chance that Blondlot was perhaps the only one practicing not sincere pseudoscience, but sincere courage, the courage to never stop saying, "I do see it." What if he, personally, never needed the phosphorescent screen that aided the eyes or imaginations of others? What if the reason Blondlot's young scientific curiosity was piqued in the first place was because he could always visually see details more clearly than others? It makes you wonder, what if he was the one person in the room whose biology made him vulnerable to a truth no instrument could catch? What if the rest were just experiencing confirmation bias, national pride, or professional loyalty? Because Blondlot was the only one, it seems, who took his conviction to the actual grave. Then, this story ends up being about the varied limits of the human eye. And perhaps the agony of being optimistically supported, then quickly doubted and quietly invalidated. But it's fair to ask whether Blondlot alone detected some other unknown phenomenon, even if not EntThe's, and whether he eventually realized that later. The screens were meant to enhance detection, yes, but for whom? Back before the screens, others agreed that they saw the changes directly in the spark, if only to be polite. But once the screens arrived, maybe Blondlot felt a quiet truth he never said aloud: that the spark itself still showed the effect, more clearly than the screens, at least to him. Yet he didn't press the point. And the screens were more for them than for him. They, of course, wouldn't trust his eyes. They'd trust only their own. So maybe in that session when Wood secretly removed the prism, what he really saw in Blondlot wasn't what it looked like. Maybe Blondlot himself wasn't highly impressed with the effect on the screens either. Maybe he felt the study slipping away from him and let himself drift with the room's loyalty, out of the steady hope of a sane man convinced by what he believed he saw. Hope that the effect he trusted so reliably would one day stand out clearly enough for everyone else to see it too. He had to rely on this hope because in science, there is no category for "they can't see what I can, but it is real and I'll prove it." He already struggled to keep everyone on board. When you know what you know, the world doesn't always know it with you. Yet, this doesn't represent a flaw in science. It represents something even harder to work with, a puzzle in the accepted human reality. Before the EntThe study, Blondlot had won 3 prizes from the French Academy of Science. He was an accomplished physicist. He was never known to simply imagine things. Yet, he would believe in EntThe until his death. But why? We may never fully find the answer.